Assalamualaikum semua. The first light behavior that we will be discussing is reflection. So what is reflection? Reflection is the return of all or part of beam of light when it encounters the boundary between two media. Remember, in order for reflection to occur, the surface for the light to return has to be a shiny surface, just like mirror. So in our syllabus, we will be only focusing on spherical surface, and there are two types of surfaces, which are the concave mirror and the convex mirror. So you can imagine your spherical surface as a one big imaginary circle, okay, where for a circle, there will be the center point. So we will label it as C. C is the center of curvature. Okay, and on the mirror, there will be a point P, which is the point at the center of the mirror. The distance between point C and point P is measured as the radius of curvature, which is denoted as capital R. In between point C and point P, we have a point which we call as focal point. So the distance between center to focal point and focal point to point P are equivalent. Okay, so the distance between focal point to the point P is what we call as focal length. Alright, so let's look the difference between a concave mirror and a convex mirror. So for concave mirror, or we call kanta cekung in Malay, where the spherical part is inward. Okay, so what will happen when light travels and hit the surface of concave? Light will be hitting and returning on focal point, okay, which is located in front of the surface. Whereas on the other hand, convex mirror or kanta cembung in Malay, having the curve outward, so when light travels and hit the surface of convex mirror, it will be diverging as if it came from one point of focal behind the mirror. Okay, so ray diagrams are very important for the topic, where ray diagrams are used to determine the image produced, as in the location of the image and also the characteristics of the image. Okay, so here I have an example of a ray diagram for concave and convex mirror. So a concave, as mentioned, is kanta cekung, where the surface is inward. Okay, so you can think of cekung as in melengkung. So melengkung ke dalam, like this. Okay, so making the focal point for concave and the point of curvature, center C, will be in front of the surface. Okay, so there are 5 different positions of object that will give you 5 different characteristics of images. Okay, the first one, we have the object located beyond the center of curvature. Okay, as in distance object U is bigger than the radius. Or we can bring object closer to the center of curvature, as in exactly on the center of curvature, which is distance U is equals to R. And then we have position of object in between point C and F, or distance object U in between R and focal length. And the fourth position will be object exactly on the focal point. Lastly, the object is lesser than the focal point. So here are the 5 different positions of object that will give you 5 different characteristics of image. So we need to know the ray diagram for each one of the position. Okay, so for the ray diagram, okay, the first ray from the object where light traveled parallelly and it hit the surface and focusing on the focal point. Okay, so this is the incident ray, and here is the reflecting ray. Okay, exactly on the focal point. So that is the first ray of light. Okay, the second ray, where we can draw from the object straight away into the focal point, and when it hit the surface, the reflected ray will be reflected parallelly to the principal axis. So here is the second ray. Okay, so where the position of the ray of lights intersect, okay, at this point where the two light rays intersect, that will be the point where your image will form. Okay, so that's how we determine, okay, the position of the image and also the characteristics of the image, where in this case we have object O behind the center of curvature, as in this one, U is bigger than R, so the image produced here is inverted, okay, and then diminish, and also real. What does it mean by inverted? Inverted means the other way around with respect to the object. Object is upright. Object is upwards, but image is downwards. Diminish means the image produced is smaller with respect to the object. So we can see from the size of the object and image here, which is slightly different in the height, where the image is smaller compared to object. And lastly, we have real. So what is real meaning? Real means the position of the image occur in front of the surface. So here we have the front surface, and then here we have the back surface. Okay, so next for convex surface atau kanta cembung. So kanta cembung, okay, the curve is upwards. So you can remember it as cembung, as in kembung. So dia punya lengkung tu ke luar. Okay, so for convex mirror, okay, or convex surface, we only have one position of object that will give us the same characteristics of image, okay, because the focal point and also the point of curvature for convex are all located at the back of the surface. Okay, so when it is at the back, right, it will be not real. Okay, because light will not be traveling at the back of the surface. Light will only appear in front of the surface because we said it is reflecting, as in it is returning back. So that means light will only travel on the front part of the surface. Okay, so how do we draw the ray diagram for a convex surface? So from the object, light travels parallelly, and then it will be diverging once the light hit the surface. So the direction of the diverging as if it come from the focal point at the back of the mirror. So notice here, when the ray diagram coming from the back of the surface, the line has to be dotted line. Why? Because like I said, light does not travel at the back of the surface. So here it's just like as if, okay, so that we have the direction of the diverging. Okay, so that is the the first ray. Okay, sorry about that. And the second ray, the light will travel directly towards the center of curvature and reflecting on the same direction. Okay, that's why you can see here there are two directions of arrow, as in it came from the object towards the center of curvature behind the mirror, and it will be returning or reflecting on the same direction. Okay, so that was the second ray. So once again, the intersection between the two rays mark the position of the image, which is located behind the surface. So that is why the characteristics for a convex mirror will always be virtual, okay, as in behind the mirror, will always be smaller, okay, with respect to the object. So here is the object, and the image height is different, and the image height is lesser than the object's height. And then we have upright. Upright means it is in the same orientation. Object is upwards, image also upwards. So that means upright, same orientation. Okay, so you need to remember how to sketch, right, the ray diagram for both types of mirror, concave and convex. Okay, so next, let's look at the calculation part. Okay, besides using ray diagrams to know the image characteristics, okay, we can also use calculation method, right, to find our position of image. Okay, so let's start with equation number 65, where we have R is equals to 2F. So be careful here. R here that we have, capital R, is not the resistance because we are no longer in electrical chapter, but capital R is the radius of curvature. Okay, ingat radius of curvature. So radius of curvature having the unit meter, or can also be in cm. Okay, and R is equals to 2F. Okay, so F here is not frequency, but it is the focal length. Okay, so since focal point is in between center and point P, that's why R is equals to 2F. Okay, and this is very important. Okay, this equation 65 is only for mirror. Okay, when we do thin lenses, you will notice why this is very important. Okay, for mirror only, that R is equals to 2F. Okay, do not confuse. And then we have equation 66, where we have 1 over F equals to 1 over U plus 1 over V. So F, once again, is the focal length. Okay, U is the object distance, which is measured from the position of the object to point P, okay, which is the mirror. Point P is the center of the mirror. So that is the distance that we measured for object, whereas V is the image distance measured from the image position to point P on the mirror. Okay, Alright, so since we have r equals to 2f, so 1 over f can also be written as 2 over r, okay, because they are equivalent. Okay, to apply this equation number 66, sign convention is very important. Okay, you have to know when to use positive sign and when to use negative sign. Okay, so let's do one by one. Okay, we'll start with the object distance u. For object distance u, it will always be positive, as in the object will always be in front of the mirror. Okay, for f, okay, positive sign will be used for concave mirror and negative sign is used for convex mirror. Lastly, for image v, positive sign is used if the image is real, as in front of the surface, and vice versa. If the position of image is behind the mirror, as in virtual, the sign convention will be negative. So, in conclusion, okay, for you to easily remember, for any position that is on the front surface, the sign convention will always be positive. And for any position that is behind the surface, the sign convention will be negative. Okay, so that's why it is important for you to remember the shape of the surface. Okay, we have concave surface. Okay, and we have convex surface. Okay, so here is the front part and here is the back part. Okay, so that's how you remember your positive and negative. That's why for convex surface, the focal length is negative because f is behind the mirror. Okay, and object u, like I said, will always be positive. Why? Because object is always placed in front. There is no way object to be at the back of surface. Okay, if object is at the back, how would light reflect? You can understand? Okay, alright, next we have equation 67. Equation 67 is about the word we call magnification, capital M, where we have the equation is negative v over u, or we can use the size of the image, m equals to hi over ho. Okay, so for magnification, it is always the ratio between the image to the object. The image to the object. It doesn't matter we look in terms of the distances or we look in terms of the size. Okay, cuma you have to be alert the negative sign. Okay, so that means magnification can also be positive or negative. So what does positive negative magnification means? If we get m to be positive, that means it is upright. Okay, if it is upright, that means it is always virtual. Okay, itu pasangan dia. Upright mesti dengan virtual. On the other hand, we have negative. Negative indicates magnification is inverted. So inverted means it is always real. Okay. Alright, so this is the sign convention. Alright, in terms of the value, okay, what does it mean kalau nilai m is bigger than 1, smaller than 1 or equal to 1? If m is equal to 1, maksudnya nilai v and nilai u adalah sama. Okay, atau hi over ho adalah sama. So dalam arti kata lain, the image is the same size as the object. Okay, but if magnification is more than 1, 1.1, 1.2 and so on, that means the image is larger than object, or we call the word magnified. Okay, and lastly, if m is less than 1.0, 0.9, 0.8 and so on, the image is smaller than object, or the keyword that we use is diminish. Okay, right? So let's look at question for a better understanding.